In our last video, we defined what we meant by inverse functions, and in this video, what we're going to discuss is how to find the inverse of a function given its rule. But let's revisit a really imperative piece of information when we discuss inverse functions, and that would be this. We say the domain of the function is equal to the range of its inverse, and vice versa. So that is, the domain of the function, these x values here, are equal to the range of the inverse function, and vice versa. The range of the original function f here is equal to the domain of the inverse function here. So basically, a necessary consequence of this is that every input that you stick into the original function sent to an output, when you put that output into the inverse function, it sends it right back to the input. So our domains and range essentially switch. And so we could say that for every point f, on the function f here, we say xy that is on the graph, we would say f inverse of x. We would say when we plug y into the inverse function, it gets sent back to the original input value. And that's basically just the consequence of us saying when I plug the y values of this function into this one, I get this. And when I plug in the y values of f into f inverse, it sends it back to the original x input. So to find the inverse of a function, the idea is that we're going to switch our domains and ranges. So we say the equation for the inverse of a function f can be found as follows. We say replace f of x with y in the equation for f of x. So in other words, we're going to write this in terms of a y. And then what we're going to do is interchange x and y. And so basically what we're going to write right next to this step is that we are switching the domain and range. Switching, let me try to write that a little bit better. The domains and ranges of the two functions. Because really that's all that's happening there. If I were to have a function f, for instance here, and it's given by the set of, 1, 2, and then 2, 4, and we'll go real simple here, 3, 6, maybe it's a doubling rule is the rule that we have here. Then f inverse, basically, all it's going to do is it's going to say, I'll take the output 2 here, you plug it into me, and I'll send you back to the original input 1. And likewise here, if you give me 4, what I'll do is I'll undo that 4 and I'll get you back to the original 2. And if you give me the 6 here and plug it into the, the inverse function, we get back to the original 3 that you wanted to get back to. So essentially what we're going to do with our function here is just wherever you see an x, we're going to switch it with a y. Wherever you see a y, you're going to switch it with an x. And then step 3 is really easy. It just says solve for y. Okay, so now I say really easy. There's going to be some algebra involved in one of these examples at the very least, but all of them, I guess. But basically, I guess we could read through the rest of this. After we solve for y, it says if this equation does not define y as a function of x, then the function f does not have an inverse function and this procedure ends. But it says if this equation does define y as a function of x, then the function f has an inverse function. And step 4 will be this. We say if f has an inverse function, replace y in step 3 by f inverse of x, and we could verify our results by showing that plugging one function into the other one, which is, it's good to check your work, but not always necessary, but something we can do to make sure that we're right. So let's look at this first example here. It says find the inverse of this function f here, the function that would undo this function's output values. And so the first thing I'm going to do is I'm going to replace my f of x with a y. So I have y equals 2x plus 7, same function. And then you'll notice I'm going to switch my color here because the moment that I do this, which is really all I've done is switched all my x's with y's and y's with x's. This right here at this point is the inverse function because we successfully switched the range of the original function to the domain of the other one, and then we say the domain of the original function is the range of this inverse function. So this is the inverse. What we want to do now is solve for the y value. So I am going to subtract 7 from both sides of this, and we can see that we get x minus 7 on the left side, and we have 2y on the right. So now I'm going to divide everything in half. And what we end up with is this y equals, I guess, x minus 7 over 2, and I guess I don't have a problem writing it as a rational expression right there. But the next thing we want to do is essentially this. We want to say, well, instead of y, we're going to write f inverse of x. And we're going to say x minus 7 over 2. And I know this is a function because we didn't get some sort of plus minus over here that's going to cause us to get two outputs for a single input. But basically, we say these two functions are inverses. If we wanted to prove it, all we have to do at this point then is compose these two functions. And I think it's a lot easier to take this bigger expression and plug it into our original expression. So here's what I want to do. I'm going to take f inverse and I'm going to plug it into f of x. And we're going to test our answer. Make sure we're right here. So we would get this. We would say, well, plugging into f of x, we get 2 times the input plus 7. And what this means is we're plugging in f inverse of x, the purported inverse function, And in this case, we know what f inverse equals. We have this x minus 7 over 2. So, you know, if they're inverses, you tend to see things like this happen really easily. Like the 2's are going to cancel out here. We get x minus 7. Suppose I'll leave it in parentheses. We say plus 7. And, you know, all of this comes down to the fact that we end up with the original input, which by definition of inverse is we're saying that f undid f inverse, and we got, you know, left with the original input here. So we have proved that these are inverses. So we're going to run over this procedure just a couple more times here in this video. And you might pause and try this on your own. But what we're going to do is find the inverse of these functions that you see here. So starting with this cubic function, we have f of x equals 4x cubed minus 1. You know, pause it, try it on your own. We're going to roll here. We say y equals 4x cubed minus 1. So let's switch our domain and range. I'm going to switch colors because we're in a new function now. We say the inverse, actually. And it would look like this. Now we're going to solve for y, which means we need to bring this 1 over to this side, which is going to give us x plus 1 is 4y cubed. And even better, before we can take the cube root of both sides, we need to divide both sides by this 4. So we're going to get this. We have x plus 1 over 4, and this is equal to y cubed. And so we will take the cube root of both sides. And you know what? I'm going to be really bad on this one. And I'm going to call this f inverse of x. I'm going to say that I'm going to leave this as just the cube root of x plus 1 over 4 without rationalizing this. And, you know, I would suggest you check this out here. If we were to say plug f inverse into f of x, we would get 4 times our cubic quantity minus 1, where this is f inverse of x. I'll have a little bit more room down here. We say 4 times. Now everything we just found here, which was the cube root of x plus 1 over 4. So we have a cube root. This was cubed. So the cubed undoes the cube root. We get c left with this, which is a very familiar thing we've been seeing now in the last couple of examples. The 4's canceling, and then, you know, we get left with x plus 1 minus 1, where the 1's cancel. We get left with x. So these are indeed inverses. So in this last example, really this is just all about the algebra. But you will see things like this from time to time. So what we are going to do is we're just going to roll with it, and I'm going to show you a way through this. So we'd say y equals 3 over x minus 1. Let's switch out our domains and ranges. We'll switch colors here. We say this is the inverse function right here. So what we could do is, since we're trying to isolate y, I suppose we could boot the 1 over to this side here. We have 3 over y. So at this point, what we're going to do is, I suppose, there are a few options. We could reciprocate both sides. I really like that idea, but just to show you what we need to do, probably most likely is multiply both sides by y, which is a very common, probably a way to approach this here. Again, you know, it's a difference of opinion. But I would say that in this case here, we would say y times x minus 1 equals 3. We'll divide both sides by the x minus 1. X minus 1. And so this is gone. Say y equals 3 over x minus 1. And so if this is the inverse, we just want to be clear on this, then we're going to write that. We're going to say rewrite this as f inverse of x. This is the undoer function, and I would encourage you to plug one of these into the other to make sure that they're inverses. But that's how you find the inverse of a function. Cheers.